finish off this first review packet, I'm going to start off with number 10, which is sketch one cycle of this trig equation. Label at least 4 points on the graph. Now, I'm a big fan of 5 points at least, so if you do what I'm about to do, makes for a pretty picture. So I'm actually going to get out a piece of scrap here and do the work on this so you can see it a little better. So first off, I'm going to put the equation in the correct order. Right now it says y equals 1 minus cos, and then parentheses it says 3x plus pi. So what I'm going to do first is rewrite it as y equals negative cos 3x plus pi plus 1. So I'm going to put it in the correct order. Now we have another issue here. Notice the 3 in front of the x. The 3 is the frequency. However, you've got to factor that out first to separate the frequency from the shift. So the next thing I'm going to do is factor out the 3, and that would make it x plus pi over 3 plus 1. All right, now I've got everything important separated. Now, when we did this topic earlier in the year, I told you guys to start from the left and work your way across, and everything you hit tells us something important. So I'm going to make my little list. And if you guys remember correctly, remember it went amplitude, frequency, period, all that kind of stuff. So we're going to start off with amplitude. The amplitude is always the absolute value of the number out in front. So the absolute value of -1 is 1. So the amplitude, which is going to tell us how far up and how far down we go from the midline, is always the absolute value of this, which is 1. Right? So that's the amplitude. The frequency is the 3. And the frequency then gives us the period. Now there's a formula for period. Do you guys remember what that is? It's 2 pi over d. And that might be something worthwhile putting on our things to know for the final exam, right? Maybe down here is period equals 2 pi over d. So what I've been doing is just throwing things on the sheet. We can always organize these better later on, but as we're hitting a formula we need in a question, I'm adding it to this list. Again, there's no reason you can't organize that better for yourselves for the text. So, amplitude, frequency. Frequency gives me the period, because this is the formula. Period, the frequency is the b. So the period here is going to be 2 pi over 3. All right, now, let me go look here so you guys can see it. So the period is 2 pi over 3. Right, so we took care of amplitude, frequency. Now this, x plus pi over 3. This is my horizontal shift. It gives me my starting point. Right? So instead of starting at the origin, this means we're going to shift our picture to the left, pi over 3. So our picture is going to start at x equals negative pi over 3. Now if we have the period and the starting point, we can combine them to get the end point. So it would be x equals, and what you always want to do is take the starting point where you start and add it to the period to get the end point. So my end point is going to be negative pi over 3 plus 2 pi over 3. We add those together, I get positive pi over 3. All right. Then finally here at the end, we get the plus 1, my vertical shift, and that gives me my midline. And the midline gives me all the ends, right? The midline will be y equals 1. That means the picture is going to shift up 1. And then the midline, from that, we can get the maximum and the minimum. And we do that by combining the midline with the amplitude. So if we know the picture's at 1, but we're going 1 above that, the maximum will happen at 2, and then 1 minus 1 is 0. Now the only other thing we have to talk about here is what that negative out in front means. That actually means something. This means the picture is going to be reflected. Reflected over the x-axis. So basically the picture is going to flip upside down. All right, now we have enough information, you guys, right, to plot this. So I go to my graph here, and I know the midline is going to be at 1. So 1, that's my midline. Right? And my maximum is going to be at 2, and my minimum is going to be here at 0. We also know the picture is going to start at negative pi over 3. So right here, there's negative pi over 3, and it's got to be done by positive pi over 3. All right, so now we're graphing sine and cosine. So if I go back to my formulas in which we need to know, so this in the box, right? What do the sine and cosine graphs look like? Y equals sine x, right? Starts at the origin, goes up and down, right? That's what a basic sine and cosine graph look like, or sine graph looks like, and cosine. Right? The difference is it starts up high, hits the x-axis, comes down, comes back up, right? So we're graphing cosine, which means we're going to start up high and end up high. However, because it's a negative graph, instead of starting at the high point, we're going to start at the low point and end at the low point, right? So we do the first point, the last point, and then we want to know where we're going to be in the middle. So if you look at the basic cosine graph, it starts up high, it ends up high, and halfway between those 2 points, we're at the low, or in this situation, we'd be at the high point. So right above 0, we're going to be up at 2. And then halfway between these two, we have to hit the midline. So there is my graph. Now the one thing I do want to know is what are the coordinates of those 2 points? Well guys, what's halfway to pi over 3? This would be negative pi over 6, right? And halfway to him would be positive pi over 6. So I actually have 5 points here. I have the point negative pi over 3, 0. Right? This would be negative pi over 6, 1. 0, 2. Positive pi over 6, 1. And positive pi over 3, 0. And that's how you would do a trig graph. You guys had gotten pretty good at those back in the day. And the key is to make this list because it's full of partial credit. That's where all your partial credit would come from. All right, next, number 11 here. You guys were pretty good at this back in the day too. Find the equation of an exponential function. All right, now we need something other than trig formulas. Here's another formula to know for the final. Formula for final. So we keep adding to the list here. We want to come down up with the formula for an exponential function. Okay? And that was f of x equals a b to the x. Okay? So that's the formula we have to use if it says exponential. So when I look at these questions, I see, as soon as I see what function they mentioned, I usually write like y equals whatever the formula is right above it, so I remember which one I'm doing. And they gave us 2 points. So what we're going to do is compare these 2 points. Now remember, this is x and y. X and y. So if I go to this, I'm doing 8 over 9 equals a b to the negative 2, right? And I'm going to compare it, so I'm going to make it look like a fraction. I'm going to compare that y to that y, which is 9 over 2, all over a b to the positive 2. Now the reason why we do it this way is because magic happens. A's cancel, right? So we eliminate a variable. You can subtract your exponents here, right? So negative 2 minus 2, so it would be b to the negative 4. And then I'm going to do keep, change, flip here. So 8 over 9 times 2 over 9, right? We end up with 16 over 81. Now, negative, I like to get rid of the negative exponent, so that means I'm going to flip him over, make it 81 over 6 of this. So what's the fourth root of 81? 3. What's the fourth root of 16? 2 equals b. Now, good question. Some of you might be thinking, well, why isn't it plus minus? Because anything you're taking an even number root of, you should usually always put plus minus. Reason I'm not putting plus minus is an exponential function, so the bases can only be positive. So I know this is the only time you don't have to remember to do the plus minus. So now I've got y equals a, 3 over 2 to the x. And then take one of these and figure out what a is. I usually like to keep my exponents positive, so I'm going to use this guy. So I'm going to do 9 over 2 equals a, 3 over 2 squared. So I get 9 over 2 equals, this would be 9/4 a. I'm going to multiply by the reciprocal here. Right, so the 9's cancel, so I end up with a equals 2. So the final answer, so let's find an equation. I'll put it up here so you guys can see it. The answer to number 11 would be y equals 2. B was 3 over 2 to the x. You could write it like that. Or you could write f of x equals 2, 3 over 2 to the x. Either one of these is fine. The big thing is you have to have the y equals or the f of x equals to get full credit. So that's the answer to number 11. Now, 12 is the only topic that I did not cover, but it takes 2 seconds to do. It's really similar work to number 11. You just haven't seen this formula before. Power function. So, I'll add it to my list. A power function would be f of x equals k x to the p, right? So k is kind of like the a. The only difference between both of these is this time x is my base, and we want to find the power, right? So these two kind of flip-flop. That's kind of how you want to think about it. An example of a power function, x squared, right? A parabola. That's a power function. So that's what we're going to figure out for this guy. So I see the word power function, and I'm going to write down y equals x k to the p. And we're going to do this exactly the same way we did this guy. I give you these 2 pieces of information. This thing right here means the x is negative 1/5 and the y is 25. And for this one, the x is 2 and the y is negative 1 over 40. So I'm going to do, again, just like number 11, plug in for x and y. So my y here is 25, so I'm doing 25 equals k. X is negative 1/5 p. And I'm going to compare it to this y. All over k 2 to the p. All right, so I'm going to start cleaning this up like last time. K's cancel, so we eliminate a variable. I'm going to do keep change flip here. So it's 25 over 1 times negative 40 over 1. It's a negative 1,000, so I end up with negative 1,000 equals, now, see how they have the same exponent? That means all we have to do is combine this and raise it to the p. Like that. So it's negative 1/5, right? Over 2 over 1, so I'm going to keep change flip that. Negative 1/5 times 1/2, so I got negative 1. Okay, so I put these guys together. I keep change flip that over here. So I have negative 1,000 equals negative 1 over 10 to the p. Now, we can make these common bases, right? What number do both 1,000 and 10 and 1/10 come from? Hope you're thinking it comes from 10, right? So this guy would be negative 10 cubed. This guy would be negative 10 to the negative 1 power, like that. Making common bases. So this now becomes negative 10 cubed equals negative 10 to the negative p power. Since the bases are the same, that means 3 has to equal negative p. So p is negative 3. So I got one piece of the puzzle. So now I come back, and then we have y equals k x to the negative 3. Pick a point, we're going to plug it in. Doesn't matter which one. So let's say I use this guy. So I do 25 equals k, negative 1 over 5 to the negative 3. So this is 25 equals k. Now, negative exponent would flip him over, right? So this would be negative 5 to the third. And negative 5 cubed is negative 125. So if I divide both sides by negative 125, I get, right? And that reduces to be negative 1/5. So my final answer for number 12 would be, now I almost wrote y equals, but this question is very specific. See how it says g of x back up in here? See g? It means I have to use g of x, not y equals. So while this one just gave me points, I could use anything I wanted to create the answer. This one, because it was written in function notation, I have to use the same letters. So it's g of x equals negative 1/5 x to the negative 3. Right? And there you go. Good way to check, if you plug in the other number into this, hopefully you get that as the answer. Right? If I plug 2 into this, right? 2 cubed is 8. 8 would flip it over, and you would get the negative 1 over 40. So you can check yourselves with these. And we'll be doing more of these in other packets. All right, and finally, I'm going to put a box on that. Last question in the first packet. For the data in the table, determine the following. Is it increasing, decreasing, or constant? Is it concave up, concave down, or linear or exponential? Okay, now, increasing, decreasing, and concavity have to do with the average rate of change, right? So we're going to do the average rate of change for these guys. Linear, exponential, usually you can tell, again, by the average rate of change, or exponential, you need to see if it's in proportion. But let's start off with doing the average rate of change of f of x. So actually, I'm going to use another piece of paper so we have a little more room. I think I have my pen. Yeah. Okay, so this is for number 13. Okay, so I'm going to do the average rate of change for f of x. All right, let's start with that. So, let's see it. So, I usually like to do 3 of them. So I'm going to do change in y, so 75 minus 65. All over 1 minus 0, right, is 10 over 1, which is 10. Then I'm going to do 85 minus 75. I know you're going to laugh at me for doing these, but I feel like I need to do a good job here. 10, right? And then the next one, 95 minus 85. Oh my goodness, it's 10. All right, so this tells me a couple of things. My average rate of change is constant. So I know for f of x, right? It's a constant, which means it's linear, right? So if the average rate of change is constant, it means it's linear, so it has no concavity, right? A straight line doesn't bend at all. So for f of x, this is the work you'd have to show. And since you would say since the average rate of change is constant, which means it's linear, so it has no concavity. So that's the deal for f of x. Now let's do g of x. I'll do it in color, right? So we do average rate of change, which is slope, right? For g of x. But technically, we can't call it slope if we don't know it's linear. This one we can actually get away with calling it slope because it's all 10. All right, here we go. 600 minus 400 And 1 minus 0. Let's see. And then we have 900 minus 600. And then when I didn't answer a question for up here, I never said if it's increasing or decreasing, so we'll have to do that in a second. What is that? Am I subtracting here? 450. Okay. Now, a couple of things, and I also forgot to mention if it's increasing or decreasing here. The average rate of change is constant, means it's linear, but it has no concavity, but I never said if it was an increasing linear function or a decreasing linear function. And you tell by whether this is positive or negative. So because it's positive, right? Because it's positive, or because the average rate of change is positive, right? It's an increasing function. And that's going to be true for this too, because the average rate of change is positive, it's an increasing function, right? So first thing I can tell by looking at average rate of change is if it's positive, it's increasing, if it's negative, it's decreasing. Okay. Next thing, these are not constant, right? This is not constant, so not linear, right? Now we can't just assume it's exponential. We got to see if it's in proportion. And what I mean by that is, I'm going to flip this over and use the back of this. If I compare the y's, and I can do that because they're going up incrementally, if I do 600 over 400, that reduces to be 6 over 4, which is 3 over 2. Then if I compare 900 to 600, it's 9 over 6, which also reduces to be 3 over 2. And then if you do the third one, 1350 over 900 would be over 90. And this will also reduce to be 3 over 2, I believe, right? If you plug 5 in both, let's see, 45, yes. So that means that this is why it's exponential, it's in proportion. So you'd have to show that work to prove it's exponential. All right. So last thing is the concavity. Now, let's look at these. Now, the fact that this was constant, that means it had no concavity. That's what made it linear. What is happening to these numbers? 200, 300, 450. They're getting bigger. If the numbers are getting bigger, so since the value of the average rate of change is increasing, it is concave up. Okay? If these numbers were getting smaller in value, then it would be concave down. So what does all this tell me? This tells me that g of x is an increasing exponential function that's concave up. That's what that would tell me. All right, you guys, that's the first packet. The first time through a few things in a very long time. I promise the packets get better the more of these you do. And you should be organizing your formulas for the final exam. I think there's maybe 1 or 2 more that might be useful, but I think we got the meat and potatoes of it up until now. All right, see you soon.